Pre-calculus. This is going to be the last section that we cover out of Chapter 7, so be prepared. We're going to have chapter test next week. I know there's one more section in our note packets, but we've been skipping that section the last couple of years, and definitely under this COVID stuff, we're definitely skipping it this year. So 7-6, that's going to be the last one that we cover. We spent a lot of time on sine and cosine. We just learned tangent and cotangent. So if you haven't already practiced tangent, cotangent, make sure you do that practice first. And now we're going to learn the last two trig functions, and that's secant and cosecant. And basically, they are based off of knowing how to do sine and cosine. All right, you're going to learn how to do the secant and cosecant graphs. That's our goals today. Remember that the secant function in trigonometry is the reciprocal of cosine. That's what they're showing here. Secant is reciprocal of cosine. So let's say cosine was 1/2. The secant would equal 2/1 or just 2. All right, at any given value of x, the y-coordinate of secant x is the reciprocal of the y-coordinate of cosine x. So if you know what the cosine is, you flip it over in order to get what the secant equals. All right, so the key points, the key values that we're going to use in our graph going across, it's really based off, you got to know what the cosine graph looks like, and then you can do what the secant graph looks like. So here's how it goes. When you got to fill in what the coordinates are at each one, it's the unit circle, and so this is a radius of 1 going up, going left, going down, going right. So this is at 1, 0. This is at 0, 1. This is at -1, 0. And down below it's at 0, -1. All right, now, in order to do our graph, we got to first draw what cosine looks like. So real quick, down here, now I can do it without doing this chart. You guys already know how to do the cosine graph. But when you do the cosine of 0, remember the cosine is the x value when you ask for cosine. Cosine Wait, I feel like this is done wrong here. At a given value of x, the y-coordinate of secant x is the reciprocal of the y-coordinate of cosine x. Why the y-coordinate? Why do they say the y-coordinate? Shouldn't it be the x-coordinate? Cosine is the x, sine is the y. So like the cosine, shouldn't it be the x-coordinate? Not the y-coordinate? Just caught that. Should be the reciprocal of the x-coordinate. For example, if I say, what's the cosine of 0? I just noticed there's a typo as I'm doing the video. Isn't that nice? If I do the cosine of 0 radians, cosine of 0 radians is the x-coordinate. That is equal to 1. What is the cosine of pi over 2? The cosine of pi over 2 is 0. What is the cosine of pi? The cosine of pi is -1. It's the x number. What's the cosine of 3 pi over 2 going straight down? That is also 0, because that's the x-coordinate. And what's the cosine of 2 pi going all the way around the circle? The cosine of 2 pi is equal to 1. The secant is the reciprocal of each one of these answers. So by knowing this, the reciprocal of that, well, that's 1/1. The reciprocal is still 1. When you have 0, that's technically 0/1. When you do the reciprocal, you get 1/0. That is undefined. That gives you a vertical asymptote, just like tan and cotan. Vertical asymptote at pi over 2. Pi over 2 is not a number that you can do secant, right? You can't plug in pi over 2 and ask for secant. I can ask for cosine, can't ask for secant. Now for -1, when you plug in -1 and you do the reciprocal of -1, that is -1. This is like -1/1. What's the reciprocal? 1/-1. It's still -1. Again, if you have 0 and you ask for what's the reciprocal, that'd be 1/0. You can't do that. That's undefined. undefined. Vertical asymptote at 3 pi over 2. We're not allowed to plug in 3 pi over 2 and ask for what's a secant. The reciprocal of 1 is going to equal 1. So what does all this mean? How do these two tie together? It's going to work like this. You draw a ghost. I just misspelled ghost. Ghost graph of cosine x. So what does cosine x look like? There's 1. There's -1. Here's 0 first, then pi over 2, then pi, then 3 pi over 2, ends with 2 pi. All right, period is 2 pi. The ghost is going to be a dotted line. And it's going to look like this. Starts up here, then it goes through here, then it bottoms out at pi, hits the x-axis again at 3 pi over 2, hits a height of 1, and then it would keep going. You ghost in the cosine graph. You get vertical asymptotes anytime it hits this x-axis. That's when it equals 0 and the reciprocal is undefined. So you get a vertical asymptote here and a vertical asymptote here. Okay. Now the dotted line isn't technically the graph. The secant graph is upside down from these curves. So the secant graph has this upside down curve here, and then it has just half of one here and half of one here. Now keep in mind, if we drew the whole cosine wave, the secant graph would keep going one up, one down, one up, one down. But this box, this window right here, is the basic secant X graph. That is the basic secant X graph. Starts at 0, ends at 2 pi at this point right here. That means the period length is 2 pi, just like cosine. Asymptotes are at pi over 2 and 3 pi over 2. What is the domain? Well, you can plug in, kind of a dumb question because it would actually change, but the domain is all real numbers except asymptotes. Kind of a dumb question. So all real numbers except pi over 2 and 3 pi over 2. Those are the numbers you can plug in for the angles. I really don't like that question being there. Now the range, there's a set of numbers that start at 1 and go up. So including 1 and then going to positive infinity. Parentheses, if you remember doing that way back semester 1. And then there's a set of numbers going from -1 down. So from, actually I got to do it backwards. Negative infinity is lower. From negative infinity up to -1. All right. The secant graph are what's solid lines here. Solid. And the two asymptotes. You would, if I was doing this in pencil, I would just erase this dotted cosine graph. Just erase that. It's the upside down U and the partial U and the partial U. That is the secant graph. That is the secant graph. All right, I forgot you got to do like a little union, a little U for union. It's this set of numbers and that set of numbers for the range. From negative infinity up to -1 and from +1 to positive infinity. Remember, range asks for what kind of y numbers show up. Got a blank page in there. All right, next part. Oh, we're gonna try one where they change up what the graph looks like. So if I did y equals secant 2x, secant 2x changes the period because they put the 2 in front. You got to first graph the points. So this is the ghost part of it. Graph the points for y equals cosine 2x. And that'll help you make the graph for y equals secant x. You'll do a reflection off of those curves. My amplitude, My amplitude is 1. The period, you take the normal period, 2 pi, and you divide it by 2. So the period is equal to pi for this example. It's equal to pi. What are my key values? Well, it's still going to start at 0. We didn't shift it left or right. It's still going to start at 0 and end at 2 pi. I'm sorry, it's going to end at pi, not 2 pi. I'm going to take pi and divide by 4. And so I'm going to get pi over 4, then pi over 2, then 3/4 pi, and pi. And those are my key values. Pi over 4, pi over 2, half pi, 3/4 pi, 1 full pi. All right. Asymptotes will happen when the cosine equals 0. So the amplitude is still 1 and -1. And you can ghost it in. I like how they just said do the points. So you could sort of say like, well, it's going to start up here like it normally does. That's going to go here. Then cosine goes here, then here, then here. And you can kind of draw that in. But we want the secant graph. So there's an asymptote anytime it crosses the x-axis. So at pi over 4 and at 3 pi over 4, there's going to be asymptotes at pi over 4 and 3 pi over 4. Now the wave, the sine graph would look like this. I couldn't help myself. I drew it in anyway. The secant graph is a reflection of that arch. And then, like, there would be a full U here, but it ends right here at 2 pi. It starts here at 0. So if we were drawing multiple waves, it would keep going. There'd be a full U and a full U, then one up and one down, and keep going and going and going. But that is what the secant graph looks like. It has that kind of shape every single time. All right, moving on. The cosecant graph. The cosecant graph, same idea. But cosecant is reciprocal of sine. Cosecant is a reciprocal of sine. At a given value of x, the y-coordinate of the cosecant is the reciprocal of the y-coordinate of sine. Notice I did y-coordinates this time. This time it's correctly y-coordinates. The other side should have been x-coordinates. All right, so we're still using the 4 left, right, up, down parts of the unit circle. Radius is 1. This is 1, 0, 0, 1, -1, 0, and 0, -1. You use the sine points, and then that helps create the cosecant points. What's the sine of 0? Now, all you're interested in to answer what the sine is what's the y value. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0 again. The sine of -1, I'm sorry, I gave it away. Sine of 3 pi over 2 is -1. And the sine of 2 pi, if you went full circle, the sine is 0. All of those are going to help us make our graph. It's still going to go from 0 to 2 pi, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the main points for secant and cosecant, just like sine and cosine. The amplitude being 1, up to 1, down to -1. It's basically the sine graph. It would go here, then down, then here, and then back up to here. It's the sine graph, and just like cosine, and just like secant, when you do cosecant, anytime it hits the x-axis, it's going to create a vertical asymptote. It's going to create these vertical asymptotes. So this one's got 3 vertical asymptotes. Now, why is that? Well, the reciprocal of 0 is undefined.